All right. Hello, everybody. This is Kubernetes Workgroup Device Management for July 22nd. Just a couple days till code freeze. So we'll try and focus on anything necessary for code freeze. Let me display the agenda. Why do I always have trouble finding that in here? There we go. Okay. So Patrick, go ahead and repeat what you said before we started the recording.
Yeah, okay. So I would like to use the opportunity to discuss whether core structured parameters for DRA are ready for GA. And to support the discussion, I've used my pull request that's linked here in the meeting notes. The one that does the final promotion of, well, it adds the V1 API, it promotes the feature gate to ADML by default. It can be turned off. So you could theoretically have a GA API where someone says, this is not stable enough for me. I disable the feature gate and the API because we are becoming enabled by default for the first time. That's what you are supposed to do. But I think that's normal practice. The bigger question for the group here is, do we think that it's ready? These are the GA criteria. I've not ticked them off completely all by myself yet because I wanted to discuss. First thing is real-world driver implementations. I know of at least 3 organizations, so I think we are covered. I ticked that off. Standardization of at least one attribute. We did that with PSTI root. It's in the latest cap with enough documentation to implement it, and there's a pending PR to have some helper code for it. So I think that's covered.
I approved that PR today. It should be merging in the next half hour, hopefully.
So allowing time for feedback, I think it has been around long enough. In alpha, longer. In beta, since 1.32. We've had lots of discussions around it. We know where it stands. We know where future enhancements are necessary, but I think the core of it has no pending feedback, nothing that needs to be or has been discussed enough, so we can take that off. I'm going to do that now if I don't hear any objections.
Sounds good to me.
Good. Let's skip the next one because that might take longer. Define kubelet restart, node bootstrap restart, driver runtime, upgrade, downgrade, failure modes. Not exactly sure what was expected. I think that refers to the work that Laura was starting. Personally, I think we have done enough with analyzing the plugin behavior and documenting that in the documentation of the kubelet for the plugin manager. I consider that sufficient, but yeah, I'm open to suggestions.
If my only question is what is meant. My only question is what is meant by driver runtime. I think the rest
I don't
of
know.
it, but I'm not sure what that means.
I don't know.
Okay.
I would not need to look at who actually asked for that particular GA criteria. I suspect it's Laura's work where she wanted to have a holistic view of all the things that can go wrong, make sure that it's documented, handled somehow. But I think this is. Yeah. I've not seen much activity from her in our dashboard. So she has lots of issues in draft status.
Okay, I know she was meeting with some folks regularly last I synced with her, but that was been a few weeks. But I do think that we've done probably more in this than many other features have done in the past, and I'm obviously we want to because we want it to be really solid, but I feel pretty confident in that we have a good understanding of it. Even if we haven't fixed everything, we've got a good understanding of it and fixed the big things.
I think so too. So let me take it off.
Maybe, one thing maybe, Patrick, that might be useful is when we talked yesterday in our Intel NVIDIA sync, you just mentioned some of the bugs that were found with the upgrade downgrade failure mode, just to kind of
Yeah.
talk through what we've done there and why we think we're confident that we've tested this properly.
So I can definitely talk about that here. So it's further down under, I don't know. I mentioned upgrade downgrade testing somewhere, I think. So what we have done, and it's the first time that I'm aware of anyone doing that systematically, is that we have automated the upgrade downgrade testing. We have version skew testing too. I think that may have been done before for other scenarios, but we are now testing the driver helper code with older kubelets. So we know that a kubelet from 1.32 works with the current control plane and the current driver, with some caveats because we haven't backported bug fixes, but overall it works. We have automated upgrade downgrade testing such that we actually restart the API server while, for example, a DRA driver continues to run on a node. And that uncovered some bugs. The helper code, for example, converts between the internally used API version, which is now going to be V1, and whatever the control plane supports. So if you're running a DRA driver compiled against Kubernetes 1.34 with Kubernetes 1.32, the helper code will convert to V1 beta 2 for you. And there was one bug in that restart scenario that I just fixed. And these are things that we only found because we are really doing some very systematic testing of potential failures that are defined here, like bootstrap restart, upgrade, downgrade. All of these is automatically tested. So I'm feeling very confident about that. We also
those automated tests are things we haven't done even in the past, right? So we have a more robust testing mechanism.
And in terms of the plugin management, there are a few other things that DRA plugins do better than device plugins ever did. Seamless upgrades is called out under implementation because it is new there for DRA drivers. You can have a daemon set with a rolling update where 2 instances run in parallel. So you never end up with a situation where your precious driver pod or your precious driver is suddenly not available on a node anymore because it was killed and couldn't be restarted or whatever. And there's also no downtime, no deletion of resource slices in that graceful handover between old and new driver instance. Connection monitoring that covers various failure scenarios that occur when the driver unexpectedly goes down. The kubelet will detect that and will then delete resource slices because that signals to the control plane that the driver is no longer available on the node. Liveness probe is added to the example driver as I requested in that meeting that Laura has been running. So I think we're fairly good. And then there's the automated downgrade testing. I talked about that already. So I think this does a lot more than we ever had for device plugins, and I'm comfortable promoting this to GA.
Sorry, I had a quick question around that. It is not regarding GA or non-GA, but an extension question. So I'm not sure if this is the right time. If you want to just run through the checklist, then I can hold it back.
Yeah, let's perhaps cover the checklist first. The last thing is in-flight work and bugs. Well, there is this one thing that you found where performance depends on the number of Go routines in the resource claim controller. We don't, I think we have a PR for that. We still need to get that merged for GA because it affects scalability. But I think that's the last remaining one that I'm aware of. Everything else has been fixed. We can go to the tracking board, but that's somewhat subjective because it's basically my list of things that I consider GA. I would be interested to hear from others whether they think anything is blocking that we haven't been tracking yet.
Not that I'm aware of.
Yeah, I don't have anything.
Yeah. I'm looking at the board now. I don't know whether you can. Yeah, you do too. So some of these are in progress. This is mostly the work that we need to do. The version skew testing I can actually probably close because we do have it. There were some ideas how to extend it further. That's why it's still open, but that's kind of optional. We have it in place. It's now open because we could always do more scenarios. That's why it's open.
And this is being documented.
This is documentation. This is part of a documentation update that I need to do this week before. Well, as part of my GA graduation documentation, that'll have that part.
Okay.
What does WAI
Yeah, that's when there
mean?
are some issues where Laura said that she wants to do something and probably hasn't. But
I'm on the call actually right now.
Okay, good.
Hi. Yeah, at least for some of them are docs. Everything except the version skew testing, I guess, one is docs related. So we're tracking those for the docs freeze. For the version skew testing, I agree. There's like some ideas on how to like improve it or do more scenarios, but I think we can pull that into a separate issue so that it's clear that it's like another addition that could be done later, and then we can clear the board like that.
Yep. Okay. Thanks for confirming. So I think I can in the track. Well, I can keep it open for the one PR from Ale on scalability, and now we can talk about scalability.
Actually, before we do that real quick,
Yeah?
can you go, John? Can you go back to the agenda doc? What's this first one? That's sorry, not the agenda doc. I meant Patrick's. Yeah, the GitHub. Here, what's this first one? That's looks like it's been closed. The one that's sorry, at the very bottom. At the very bottom. Sorry, John. In the last bullet, that first one, it looks like it's a PR that's been closed.
Yeah, we replaced that with something else.
Okay.
It was mentioned in the CAP. That's why I copied it. But it was solved. It's connection monitoring.
Yeah, this was resolved by the connection monitoring PR. It was like replaced.
Yes. That was the initial PR for the initial implementation. We then merged something else with. That's why it shows up as not resolved.
As not, yeah. Got it. Okay. It just looks confusing in this view. It's like we just decided not to do it with no justification.
I could edit the description to just replace it with the other one. I'll do that just to avoid confusion.
Okay, so the scalability then.
Actually, one last question before we move to scalability. So, Patrick, you mentioned that we have code in place which would detect if the plugin goes or loses connection, and Kubelet will detect it. I'm wondering, like, if I have a use case where I want to detect all the nodes that have lost connection, is that something we can plumb it to external projects like Node Problem Detector, and then kick off some kind of like kubelet restart or node restart automatically?
Yeah, we were discussing, I think, to have a metric for registered plugins. I don't think we actually implemented that metric, but it could be added. So I should add perhaps that for metrics, we looked at a few that we have had since a while, and we figured that we are still making changes to those. For example, for the when Rita implemented the admin access metrics, she found that the tracking of created claims should better use a different style of metrics instead of distinguishing between having two metrics. A metric vector, a gauge vector, is a better solution. So this really is actually will change one of those metrics that we've had for a while. So overall, with SIG instrumentation, we agreed that we are not promoting any metrics quite yet, even for things that are relevant for GA. And promoting those metrics will be on a separate track. We basically need to figure out a bit more what's relevant for observability, how well the existing metrics work. And once we have that kind of feedback, we can think about promoting those to beta and stabilizing them. And what you just asked about, can we expose registered plugins as that the kubelet is aware? I think that could be a kubelet metric.
Okay.
Yeah, I'm trying to find a reference for it too, but there's also some talk at one point, and not GA related, but like enhancement related, about having that type of status as like an enhancement in the API somewhere too. I don't know. I'm trying to like find the reference for you, so I'll grab that too, and we can discuss whether that's relevant for what you're looking for.
Yeah, sure. Okay, thank you.
Okay.
Yeah, I'll follow up on that async.
Yeah. So talking about scalability, Ale, this probably would be your chance to report. Perhaps we can just look at your Google Doc. I would like to start by saying that running these scale tests definitely has turned out to be a challenge in terms of just getting the cluster up, getting jobs to run, getting the jobs defined such that they don't fall over for unrelated problems. So thanks of all first for all the time that you already spent on this. It's not yet well, but I don't want to spoil the surprise. Perhaps you can just take the floor and walk us through what we have and where we are, and then we can talk about whether it's good enough.
Yeah, sure. So, John, if you can click the left-hand side, the three sidebar button. Yeah. Okay. So that's basically the agenda that I want to talk through today. There has been a very strong guidance that the target for GA was that we want to do some kind of test where we run 5,000 node cluster and then run workloads on that. So that is what we are shooting for. But in order to get there in our CI infrastructure, we need to first prove that we have a 100 node CI scale test that is passing consistently. Once that is done, only then it would be allowed to promote to 5,000 node cluster, just to make sure resources are utilized and there are no flakes in there. So with that context, we started off running the 100 node CI tests. And it took a little bit of time due to flakes and other related issues to get it go green. This morning was the first time where we found it consistently going green. So I want to report two major learnings out of this test. So in the table that you see right under 100 node CI test, there is a metric for pod startup. This is during the churn phase. So the test starts off, fills up 90% of the cluster, and then churns the remaining 10% of the capacity. You can see that the first two rows, the first one is baseline, that is no DRA enabled workload. So basically we don't have resource claim field in the pod spec. With that one, the test is hitting P99 of 3 seconds, but with the DRA in the second row, the test was hitting P99 of 64 seconds. So that was significantly higher than the baseline that was observed. So we went through a debugging exercise on why that was happening, and then
Sorry, can I ask a
Yeah,
quick
go
question there? So is that an average startup time over some number of pods, or how does that number get generated?
So that was the 99th percentile, not the average. So that was a very high skewed towards the worst case scenario. The average would be closer to 30, I would say. but yeah, it's basically reporting worst case over, I would say 800 pods.
Okay, got it. Yeah, so 800 pods got launched, and then this is the top 10 and top 1% worst
Yeah.
case. Yeah,
Yes.
got it. Okay.
Yeah. So that was what we were debugging. So in the fourth row, you can see the pod create to schedule latency with DRA. In the third row, it is 0 because there is no DRA workload. So scheduler does not spend any time there. But in the fourth row, you can see it is 62 seconds, right? So that means a lot of time is spent in the scheduling phase of the entire pod lifecycle. Now, debugging these failures in CI has been challenging because one, we don't have verbose logging in there because that's the recommended production environment setup. And even if we enable verbose logging, I think the way Azure logging works is it will kind of overwrite the previous logs. So it does log rotation at some interval. And then at the end, when the test collects logs, the important bits of the test were found missing. So I think I have a to-do on my plate to report and create an issue on this, but it turned out that we needed another way to reproduce this. So so I used a Quark to simulate those nodes and kind of reproduce this same problem in the local environment. And if you go back above to the above table, again, you can see the fifth row, the fifth row with local Quark and DRA enabled. We were actually able to reproduce this worst case scenario, right? So we are getting close to 85 seconds, which is similar, I would say, in terms of performance. So with that, we were able to get extensive logging and metrics. And in the next page, I can go through the metrics, what we observed. So the first thing we observed is that the Kube controller manager, I think there is a typo in there, a Kube controller manager, resource claim controller, work queue depth was shooting up really high. It was observed to go to 1.4K items in the queue. And then for processing each of the item in the queue, the controller was taking around 10 seconds. So it was spending a lot of time in processing the resource claim. And just to give some context, the resource claim controller actually, it creates the, so once you have the resource claim template and you start a pod from that template, it is the one that is creating the resource claim for the for that particular template. And because this is in the path of create to scheduling latency, we found that this was the bottleneck. And then in the third chart, you can see, if you can scroll down, yeah, that one. That again, the work queue duration of job compared to resource claim, the resource claim one was really high. And it was capping at 10, but I feel like this is the metric bucket hitting the limits. I think the actual observations were much higher than 10. So clearly this was the bottleneck, and the bottleneck came from the fact that on the kind cluster, the QPS and burst defaults were really low. So we bumped up. So the second point in the suggestions, we bumped the QPS and burst value to 200 and 400 respectively, and that brought down the latency from 63 to 3 seconds. And this was then put in the test infra on Azure side of things. And again, we observed that the churn phase latency went down from 63 to 3 seconds. So
Is that this number here?
that is with Quark, but I actually don't have a row, but I observed in the CI tests as well, we are hitting the same numbers for the churn phase.
So they brought down for the Quark, it brought it down from 77 seconds to 85 seconds. Okay. Awesome. Okay.
Yeah, so that was the problem number one. I think we should capture this somewhere. It will be very helpful for people running things at scale. The second problem was for the first phase, which is fast fill pod startup. So we took care of the churn phase with the QPS and burst values, but again, tests were failing. Yeah, go ahead.
So just for others, so the way the tests work, I mentioned it earlier, but to be clear, the fast fill is like just bring up a whole bunch of pods up to 90% capacity and then continuously churn the last 10%. So that's what he means by the two different phases.
Yeah, thank you. Yeah, so now the second problem was for the fast fill phase. The SLOs for these tests are strictly limited to 5 seconds. And what we observed is the fast fill phase sometimes goes a little bit above 5.03. Sometimes it goes more than 5, like 8 seconds or something. It was really getting up and down. And when we drill down to the scheduling latency, we see that it is always around 1 second. The scheduler does not perform worse than 1 second. So it was blazingly fast. The issue turned out to be with the kubelet. As you can see in the third row, the schedule to run latency, once the pod lands on the node, the actual running of the pod was where most of the time was spent. And you can see around 4 seconds here in the test that I looked at. But it was really, going up and down, and it was really driving that pod startup latency. So we tried a bunch of things here, but the root cause that was found was in the logs below. So if you look at that log, the slow pod log, just a little bit up, you'll see that there is a field called last finished pulling. So that is actually the timestamp where kubelet stopped pulling the image. And then you can corroborate this in the containerd logs that for pulling the particular image that was used in the workload, it took around 5 seconds just for the containerd to pull this image. So that was driving a lot of our latency here. We did a test run where we were pre-fetching the image on every node by running a daemon set. So that will make sure that kubelet is primed for running these workloads, and then start fast fill and churn phases. And with that, today morning, the tests are going green. So looking forward, I foresee these tests to stabilize. And I think we'll be trying the 1,000 node Azure test soon. Thanks to Jack, he has a PR up to get that quota. Yeah, and before going forward, I want to take a pause here. Are there any questions? I see a couple in the chat. Oh, never mind.
So just to summarize, the 100 node test, initially you found DRA performed much worse. You found some configuration issues effectively, sizing issues for the resource claim controller. You fixed it. You found a prefetch issue. You fixed it. And now everything's looking pretty much on par. So it's like from a GA, like from a project perspective, the first thing is we don't slow down when people aren't using DRA. And I think that the existing scale tests for Kubernetes would have told us already if we were doing that. And so then the second criteria, which has more judgment call, is do we, how badly do we affect it when we are being used? And it looks like, at least in the P90 and P99, I didn't see the P50, but the P90, P99 were basically the same if we have the right, I mean, it's marginally different, right? Like 10% worse, but that's acceptable in my mind for the additional work we're doing.
Yeah,
Yeah,
the
I have a
P50 is
question about
actually.
the.
Go ahead.
Sorry,
Sorry.
I just have a question about the. Actually, go ahead and finish that thought because it goes on to what John had asked. Go ahead.
Oh, okay.
P50.
The P50 is actually turning out to be 0 seconds. And the reason for that is the way these tests measure scheduling latency is that once the pod is created, there is an event which gives out scheduling pod scheduled timestamp. And all of these timestamps in the API are at second level granularity. So we can only get either 0 observation or 1 second observation. We don't get in between. So the P50 was actually turning out to be 0 seconds for those pods which were, faster than 1 second.
Okay. Whether there's DRA or not. So unmeasurably, based on our granularity, unmeasurably different.
Yeah, go ahead, Kevin.
Yeah, no, my question was just, so there was this configuration problem. Is the idea, or maybe you've already done this, are we going to just change the defaults to these higher values? Or is it up to the admin to toggle these to be acceptable for DRA?
Yeah, I think it would be up to the admin, depending on what kind of scale and throughput that cluster is going to serve. The admin can make a decision. What I was thinking is that once we have the larger scale test setup in CI, we'll publish the control plane specs, hardware specs, the throughput and the numbers that work in CI, and that will become the guidance for folks to configure their clusters the way they want to. That makes sense.
What I saw in the PR review, we just increased the default and we didn't add a configuration option for it. And then somebody was asking, why don't we add a configuration option? Like this morning, I thought I saw that.
So that was for a different issue that we found in the 100 node test. That was not the QPS and burst that we just went through. I was talking specifically for the QPS.
Yeah. Oh, okay.
So the QPS is actually a Kube Controller Manager wide setting. It's not per controller in the Kube Controller Manager. I don't think they even have a concept of having individual config settings for that. And it may become obsolete with what is it called? Fair sharing?
API priority and fairness.
Yeah. So that is covered in the sense that there is a toggle in the Kube Controller Manager. The one that has this fixed value, the one that John just mentioned, is also the one that I referred to earlier, where we have to make one change. There is in the Kube control in the resource claim controller a variable basically that is always 1 at the moment for numbers of worker go routines that handle resource claims. We never had really looked at whether 1 is enough until Ale started doing his work, and he found that it's not. This is the go routine that needs to make API calls. So it's once you start thinking about it, it's kind of obvious that if you want to overlap work on multiple claims in parallel, you need more than 1. He did his analysis with 50, which may be too high. And it certainly would be nice to have a configuration option for it, but that would then imply kind of an API change for the Kube Controller Manager. We need to have a proper configuration, command line option, whatever it takes to actually plumb in a configurable way of configuring this setting. So the current thinking between Ale and myself was that we just bump up the default and have idle go routines that don't do anything if the load is low, but are ready to kick in if it's higher.
So I think I raised a PR for that, Patrick, and somebody requested to make this a configurable setting, citing that change is not actually user-facing API.
Is it
So
not?
we
It's
It
admin
is
facing.
a flag, or if it's that's considered user-facing API.
Yes.
It's not on a resource, but it's still user-facing API. It needs API review. Like,
Yes.
okay.
That's
At
why.
least-
That's why I
Yeah.
was a bit reluctant to just jump in and say yes. Of course, we do an option. We have done that with a filter timeout. It got a separate feature gate, so you can't or you can disable support for scheduler filter timeout, but it is a considerable amount of work to get such a flag properly implemented, feature gated, and all of that. And I wouldn't like to start that right now.
That's no
I
chance.
think it's much safer to just bump it up and say that if we find that there is a need, we do this beta on by default feature gate for a new configuration option later on.
So the complaint was that, well, how much does this increase memory usage? It's got to be completely negligible, because if they're just sitting there idle, like Go routine is very light.
Yeah. Yeah, that was
I
my
agree.
response as well, that it will only be reflected when there is high load on the controller. And in that case, the resource utilization is actually justified. So you can theoretically artificially constrain that by giving controller manager less CPU. And yeah, I think I agree with it.
Okay. So did you reply to that NLA already?
Yeah.
Okay, awesome. Thank you.
Yeah.
Sorry to take you off course. Go ahead, and we have 20 minutes left. Let's try to get through the rest of this before we do, like Kevin said, we want to try at least run through quickly. I put a list of I might have missed some, so anybody look at the agenda. I put a list of the features, and I wanted to at least run through them quickly and spend 5 or 10 minutes on that. So if you can wrap this up in 10 minutes, that would be great.
Yeah,
I mean,
I'll
so
do that.
actually, real quick for you, I think hopefully the goal of Ale going through all this is that when he's done, we make a call whether we think this is sufficient at this point. And then when he runs the 5,000 node test, we think that we've now satisfied this criteria. That's the goal of walking through this, right? Yep. Okay.
Well, I also would like to know whether we wait for a successful 5,000 node run, because that might take longer than code freeze.
Yeah, I think let's go through it. I think we can make a more informed decision in about 10 minutes. So if you can click the 100 node simulation test in the agenda, that's where we were, 1,000 nodes, sorry. Yeah, here. So the next thing I did was, because the CI infrastructure was no-go for more than 100 nodes, I continued scale testing the Quark environment with 1,000 node. And with 1,000 fake nodes, I get about 8,000 fake GPU devices. So with that, I found that the fast fill pod startup latency was coming up to about 1 second. This was amazingly fast. So one thing I did in this particular test is completely disable the QPN and burst that we hit in problem number 1. So the idea here was to remove auxiliary things that could have caused issues and just make the system as fast as possible. Obviously, this is not recommended in production. SIG Scalability said that there are some outstanding known issues with API priority and fairness, where it is not able to do correct accounting of, let's say, like a watch call or a list call. So for that reason, QPS and burst configuration are always recommended as a backup mechanism to stop overwhelming API server or the control plane. But for our test, I just completely disabled it and saw great performance. The churn phase is where there was a little bit of problem observed. So if you can see, it is taking 138 seconds, about well, more than 2 minutes.
Oh,
Here.
okay. Do we have a baseline without DRA?
For this, no.
Okay, well, we have it on the
don't.
100 node test, so which should be even better than the 1,000 nodes. So if we, okay, go ahead.
Yeah, I was not sure if a baseline here was required because since this was a simulated environment, I had graphs and everything in my, in my debugging environment to look at. And if you look at the graph below, the symptoms were little bit different than the earlier graphs. So you can see that the resource claim controller add rate is really high. It was actually second largest after garbage collector controller. And then on the second graph, you can see that the depth was highest for the resource claim controller. And the difference between the last set of graphs and this one was that the amount of time resource claim controller took to process one item from that queue was actually reasonably low in the third graph. It was under 1 second, 0.3 second. So that means that the resource claim controller is doing work and it's doing at a quick rate, but the amount of things that are added to the queue is larger than the amount of things that are clearing out of the queue. So this was the symptom where what Patrick was saying earlier, we bumped up the concurrency level from 10 to 50. And with that, we got good performance again. We were back to around 3 seconds.
Awesome.
Yeah.
Okay.
So we were good with the 1,000 node test. The next thing was 5,000 node simulated testing. I tried this a couple times, and both of the times I found the same observation. And the observations are that the pod startup latency are going way higher for the 5,000 node cluster, close to 14 minutes in the first case and about 2 hours in the second case. Although the fast fill pod startup latency is that high, if you look at the scheduling latency, both in the fast fill and the churn phase, it is still up to 1 second. So we are not regressing on the rows that are highlighted in green. The things that we are regressing on is the schedule to run, which is in this case, in the real cluster, it's kubelet. In this case, it's the Quark controller that is lagging behind in this 5,000 node simulated environment. And really the fourth row, which is in red, which is fast fill watch event latency, that is the driving factor of that Quark controller being slow, because the watch, the watch that it gets and it needs to react on the pod, it is delivered at a really slow pace. So my thesis for this observation is that I am overwhelming the kind network, the Docker network on my simulation, because the CPU and memory on the system look fine. It's just the watch events and the Quark controllers getting slow. And I tried this couple times. Both of the times I got the same observations and the symptoms.
So in the interest of time, so I think that to me, the thing we really wanted to check with the 5,000 node test was whether there was any like n squared type of behavior for the control plane side. The kubelet side, which is sounding like where you're running into the problem, the fake kubelet in this case, actually is right. We know that other than the watch, which every pod will have, regardless of whether there's a for lots of reasons, that scales linearly with number of nodes effectively, right? Like so from my point of view, I guess this seems okay, right? The fact that we got through the control plane side and the control plane was done with its work very quickly, even in all of these phases, and what we were waiting on was just watch events getting delivered to kubelets and pod executing, which when you have 5,000 kubelets instead of, I was at just one Quark pulling off that queue, it'll probably go a lot faster. So I personally, this is encouraging, I guess I would say.
Yeah, I agree with you. The green rows look very promising for me.
I added one section about scheduler perf results. They are also fairly good. I've not run on 5,000 node scale because it takes a long time just to set it up, even on a local machine, even without kubelet. But scheduling performance throughput is fairly high, so I'm also comfortable with where we are.
So I think one thing I want to make sure, since there was a lot of time invested in this already between the code freeze and the feature freeze, I'd like to strive and get these tests in the CI so we can actually publish these numbers officially. And I think I need a little bit of help on the reviews. So all the items that are in that line of things are in the checklist in this document. So I'll ping related folks offline, to make progress on this. But that is my goal to get this in the CI before we actually make this 134 release.
I fully agree that's a worthwhile goal. I still would like to not block GA on completing that work because we basically need to get the V1 graduation done fairly soon, ideally before, not on the last day of code freeze.
Yeah, no, I agree with that.
With the idea being that Ali's done his due diligence, we've gone through this, we've seen the results, and we're confident that it does have the scaling characteristics that we expect and want. And it's just going to potentially take longer to get these put into the repeatable CI. Yep, I'm comfortable with that as well.
Okay, awesome. So I think that what we're saying is, and somebody object if they disagree, I think what we're saying is that as a group, we're confident in the scalability of this. And so, Patrick, do we have the SIG scalability approve the V1 or
they are out of office right now, effectively.
Okay.
So that is unfortunately a no.
Okay, but it is not on the, I mean, it's not in the tooling that it's required or in the process that it's required.
I don't think so.
Okay.
They were advising in some sense, but I don't think we are gated on them unless we think that we should be.
I think we're confident, one, the baseline already is okay, right? We're like, we know that we're not materially affecting scalability when you're not using resource claims. And two, even when you are using resource claims, Alay's tests show that we scale well with maybe an additional 10% latency, at least on the P90 and P99 levels, and unmeasurable based on our infrastructure at the P50 levels. So to me, like, and then that's basically both at 1,000 and 5,000 node simulations, because the 5,000 node simulation issues we're seeing right now are not related to the DRA control plane code, but to the simulated environment. So I feel pretty confident that we can go ahead with GA and we can check this off the list.
Okay, then I'll go ahead and do that if I still have my PR open somewhere. I just need to find it again. It went somewhere.
Thank you, Alay. This is awesome work. Really, really critical to getting us where we are. So really appreciate it.
I fully agree with that, yes. Okay, we don't have much time left. So we talked about my V1 PR. Status at this point is it needs API review. I think Jordan is going to look at it soonish, I hope.
As soon as you tell him, he will look.
Yeah, okay.
Tell him now. Tell him today. He'll. I mean, it's.
Yeah.
Yeah.
Good. I'll do that. I think it's ready. And that would be GA graduation. We have consumable. Let's talk about the other outstanding topics. Consumable capacity. It was blocked by an API issue. That API issue around having optional map keys got
Mhm.
resolved between myself, Joe, and Jordan last week. So we unblocked consumable capacity API changes to use an optional list map key in the resource claim status. And Pang has been updating it today. I think yesterday there was a public holiday in Japan. Mix-ins, we identified, well, I asked Morten to consider how large a resource slice can become in the worst case. And when he did that experiment, he found that we were missing certain limits. And he has added those since then. I LGTM'd the mix-ins PR. It will go alpha. It's, I think, ready for another, it's ready for API review.
Whose approval is missing?
API review, I think.
And SIG scheduling?
Maybe. Actually, I'm not sure. It might be one of those things that don't require changes in the core scheduler code in the plugin.
It's
It's
just, it
entirely
expands. Yeah.
it's
But
entirely in the allocator,
Okay,
and that
okay.
is something that is.
I know,
But
I
they
saw
are
Matt-
looking.
I saw
Yeah,
Malte in there, so I know it's being reviewed, but okay.
yes.
What about
Yeah,
consumable?
unfortunately, I cannot confirm because I was out of office, and
Okay.
today I'm the first day. By the way, next week I will be on vacation, so
Next week is after code freeze, but that means that's relevant
is,
because
it is.
some of these might need an extension, and then we have the question again of actually do we have someone to review next week? I'll also I also plan to be on vacation after code freeze. I might have to be around for a bit longer, but that was at least the plan. So yeah, consumable capacity needs some code changes. Probably needs a final API review, but Jordan has been looking at it already.
And then it'll need SIG scheduling approval once it's got all the code changes done.
Yeah. So mix-ins, I just mentioned. Extended resources, I've been looking at that extensively. The concept is clear, but the code isn't that clear. There are a lot of things where I think both Margie and I have been just scratching our heads about what does the code really do, because it lacked comments. It wasn't very clear. And I think today I went through it more thoroughly and trying to clean it up myself, and I found, I think, at least some cases that are just not handled yet, because there's just no code for them, or the code hasn't considered some certain corner cases. So I'm not sure about this one, to be honest.
Okay.
Yeah, I'd mark this at risk for sure.
It's at risk. We either get it into a better shape very soon, very quickly, or it'll just have to wait. I don't know yet.
Okay. Okay. I hope not.
Yeah.
This is ready, I believe, and
yeah, I think it's ready. I'm not even sure what it's blocked on.
I don't think it's blocked on anything. I think it's just waiting for final. There's a feature gate, feature approver.
So
because it's bumping to beta.
Yeah, one thing that's missing from this list is the pod resources API, and it's in that same state. It's ready, but needs feature approval.
Okay. It just needs a feature approver?
Yep.
Okay. And is somebody assigned to it?
I don't know, but I'll make sure they get assigned.
Okay.
Admin access is planning to go beta. Rita has done quite a bit of work on metrics, for example, on adding tests. It's almost ready. I looked at the GA criteria, beta criteria, and the only thing missing was the automated upgrade downgrade testing. But she has a pending PR. I just need to merge it, and I think then it's ready for beta. And then needs also feature approval.
Okay.
Binding conditions. I think my latest review was finding some issues and it's being updated and addressed. So still going through some code changes. And there were some discussion, I think with the scheduling, whether it's ready, but I think overall it's coming up okay.
Okay, so Dominic, you don't know because you've been out and Matcha's not here, I think. So this one I know we were last I checked.
Yeah. They are in reasonable shape. If anybody interested, take a look. I think JP is cleaning up all this request to rename something or do some like end-to-end testing. So I think it will be on track.
Okay. Okay, and that's mostly Signode, right? That needs to do that. That needs to approve that. Renal.
Yeah,
I know. I
there is
saw
no
Renal-
API change. Yeah, it's the same API.
Okay. Okay. Awesome. Anything else we need since we have 2 minutes left? Did I miss anything here?
I don't think we missed anything, but I want to just ask what we can do to de-risk this extended resources one, because I'm in the same kind of boat as you. We can't, I'd really like to get this in, this release if we can. Yeah.
So Patrick was, like you said, dug into it deeply and was gonna offer some direct code suggestions.
I did that. I finished that today. Whether the alternative is now any more reasonable than before is, of course, a bit subjective. It would be interesting to get a second opinion. I don't know whether that helps, but there is an updated version of a code that I find a bit easier to understand.
Okay, and so are there cases, you said there were some cases you think that were missed?
The error recovery, if a special resource claim has been allocated and then pod scheduling fails, it's kind of error handling. So it's not the normal case, but recovery in abnormal situations, I think that particular case where it's allocated and needs to be deallocated, that's just not handled yet and doesn't have test cases.
Okay, but I assume that was in your comment in the PR, so I
Yes.
can follow up with you
Yes.
and see if, okay.
Yeah.
Okay, well, yeah, I mean, I think, yeah, I can double check with you. I don't know, YU, not YOU. And I'm not sure more hands is gonna help there. We just need to try and, Patrick's been very, very, reviewing it very closely. So I'll see if there's anything you needs.
Does the author, his name's you, is that what you said? Does
Yeah.
he, it's confusing because you said you, now I understand what you meant a second ago. He, is he available to actually make all these changes and push this
Yes,
through?
I believe so.
3 days?
He's been making changes.
Mhm.
And I can sync with him and make sure his schedule is clear to respond quickly. Probably what would help, is those of us in this time zone to be available so that there's less time zone latency. And Patrick's not staying up to all hours. So I can try to take a closer look there too.
Great.
Some
I'll
of
do,
these are
once he makes, sorry, go ahead.
Some of these are easy things, like not
Okay.
using Go properly. Anyone could review and get that fixed before it hits another full review round. So, yeah.
Okay, sounds good. All right, we're out of time. Thank you, everybody.
Great, thanks.
Yep.
Thanks.